Today we are going to solve this problem, number of subsequence that satisfy the given sum condition. So it's LeetCode problem 1498. So before understanding the problem, let's understand what a subsequence is. Okay, let's take this array on 3, 3, 5, 6, 7. Let's take this array. Take this array 3, 5, 6, 7. Okay, so subsequence means pick any element from the array. Pick any element from the array in any combination. Okay, we can pick the element in any combination but the original order. Okay, so we can pick any numbers in the array, so the in any combination, so but we have to keep their original order. Okay, so let's see. Pick any element from the array in any combination but keep their original order. Okay, so it was clear now. So some subsequence are be this 3, 5, 3, 5, 3, 6, 3, 5, 6, and it will be 3, 5, 6, 7. Okay, so let me make like this. So we have array like 3, 5, 6, 7. So 3, 5, 3, 5, 3, 6, 3, 5, 6, and 3, 5, 6, 7. So the rule is, so and there are many more. So the rule is you cannot change the order. So we have not changed the order. We have take 3. Next we have take 5. Then we have take 3 and 5. And then we have take 3 and 6. We have not take 6 and 3. We cannot change the order. Okay, we can pick any element from the array but we cannot change the order. Okay, now what is the problem is asking. See, we are given an array of nums and a number target. Okay, so for every subsequence we look at two things: the minimum element in that subsequence and the maximum element in that subsequence. So if see, so the problem is if minimum plus maximum is less than or equal to target, minimum plus maximum is less than or equal to target, so that subsequence is valid. Okay, so we have to count all valid subsequence and return the count. Okay, so let's see, let's take a small example. Let's understand subsequence properly with this example 1, 2, 3. So now subsequence is pick any element you want. You can pick one element, two element all three. Okay, so all possible subsequence are 1, 2, 1, 2, 1, 3, 2, 3, 1, 2, 3. Okay, so see, total 1, 2, 3, 4, 5, 6. Okay, so total there are 7 subsequence. Okay, now notice one thing in this, in every subsequence the minimum, so see, the minimum is the smallest element. Okay, and the maximum is the largest element. So minimum is the smallest element and the largest element is this. Okay, maximum is the largest element. So in this minimum also 1, and so if we take first this subsequence, in 1 minimum also is 1 and maximum also is 1. Okay, so in this minimum also 2 and maximum also 2. Okay, so in this okay, 1 and 3, minimum is 1 and maximum is 2. Now take this, minimum is 1 and maximum is 3. Now take this, minimum is 2 and maximum is 3. Now I'll take this one, minimum is 1 and maximum is 3. Okay, so this is the key things to understand. Okay, now what does the problem actually check? For every subsequence we only care about the smallest element, that is minimum, and the largest element, and that is maximum. We just care about smallest element minimum and the largest element maximum, so we completely ignore everything in between. Okay, we completely ignore everything in between. Okay, so for 1 2 3 now, so we only care that minimum is 1 and maximum is 3, and the 2 is in the middle, so we do not care about it for the condition check. So the condition is minimum plus maximum must be less than or equal to target. Okay, now say let's take this example only. 1 2 3 and target we take 4. Okay, now let's take every subsequence. First take 1. First we take 1. Okay, so minimum is 1 and maximum is 1. 1 plus 1 is 2. 1 plus 1 is 2, so 2 is less than or equal to 4. So yes, we take this. Okay, now our count is 1. Next is 2. Next subsequence is 2, so the minimum is 2 and maximum is 2. So 2 plus 2 is 4. So 4 is less than or equal to 4, is less than or equal to our target, so we take this count also because it equal to our target. Okay, so now our count become 2. Equal is valid. Okay, now we take this 3. So minimum is 3 and maximum is 3. So 3 plus 3 is 6. So 6 is less than or equal to 4. No, 6 is greater than 4. So we skip this. Okay, it was too big. We skip this subsequence. Now we take 1 and 2. 1 2. Minimum is 1 and maximum is 2. So 1 plus 2 is 3. So 3 is less than or equal to 4. Yes, so we take this. Okay, now our count becomes 3. Now 1 and 3. 1 and 3. Okay, minimum is 1 and maximum is 3. 3 plus 1 is 4. 4 is less than or equal to 4. Yes, so we take this subsequence and our count become 4. Okay, 1 and 3. Next we take 2 and 3. Okay, next we take 2 and 3. So minimum is 2 and maximum is 3. So 2 plus 3 is 5. So 5 is less than or equal to 4. No, it was invalid, so we skip because 5 is greater than our target, so we skip this. Okay, our count stays same 4. Now we take full array 1 2 3 2 3. Okay, so the minimum is 1 and the maximum is 3. So 1 plus 3 is 4. So 4 is less than or equal to 4. Yes, so we take this. Now our count become 5. Okay, so what is the valid subsequence are 1 2 1 2 1 3 and 1 2 3. Okay, so the answer is 5. Now let's take one more example. Wait. Okay, let's take one more example. So we have 3 5 6 7 and target is 9. Okay, now let me show you something interesting here. Look at, see, 3 5 6. Okay, look at 3 5 6. Min is 3. Okay, min is 3 and max is 6. So 3 plus 6 is 9. So S, and look at 3 and 6. 3 and 6. So min is 3 and max is 6. So 3 plus 6 is 9. Okay, so see, both have the same min and max, so that middle element 5, it does not affect the condition at all. Okay, so this is the most important observations in this problem. So the element in the middle do not, so in the element in the middle does not matter. Okay, so it do not matter. For the condition only min and max matter. Okay, so let's check our subsequence. Let's take this example. Let's check our subsequence of this. First we take single element. Okay, single element subsequence are when subsequence has only one element, the element is both a min and max only. Okay, so the first is 3, only one element, so min also 3 and max also 3. Okay, min also 3 and max also 3, so 3 plus 3 is 6. Okay, now our target is 9, so it was 6. So 6 is less than or equal to 9 years, so we take this. Okay, our count become 1. Next one is 5, so the min is 5 and the max is 5. 5 plus 5 is 10. 10 is less than or equal to 9 because 10 is greater, so we cannot take, we skip this. Okay, no, we have 6, 6, 7. Okay, now take 6 and 7. Okay, 6, min is 6 and max is also 6. 6 plus 6 is 12, so 12 is less than or equal to 9. No, because 12 is greater than 9, so we skip this. Now last is 7. Min is 7 and max is 7. 7 plus 7 is 14. 14 is less than or equal to 9. No, because 14 is greater than 9, so we skip this. Okay, so from single elements the valid one is only 3 is valid. Okay, so the only 3 is valid, so we here write 3. Now take two element of subsequence 5, 3, 6, 7, 3 and 5. So the min is 3 and max is 5, so 3 is smallest and 5 is large, so 3 plus 5 is 8, so 8 is less than or equal to 9. Yes, now our count become 2. Okay, we take this also. Next is 3 and 6, so 3 is smallest and 6 is maximum, so 3 is smallest and 6 is largest, so 3 plus 6 is 9. So 9 is less than or equal to 9. Yes, so we take this one also. Now our count become 3. Next is 9 is equal to target. Okay, 9 is equal to target and equal is allowed. Next is 3 and 7. 3 is smallest and 7 is largest, so 3 plus 7 is 10. 7, 8, 9, 10. So 10 is less than or equal to 9. No, just one more than target, so it fails. Okay, next we take 5 and 6. So 5 is smallest and 6 is largest. 5 plus 6 is 11, so 11 is less than or equal to 9. No, we skip this. Now we take 5 and 7. 5 is smallest and 7 is largest, so 5 plus 7 is 12. 12 is less than or equal to 9. No. Now we take 6 and 7. 6 is smallest and 7 is large, so 6 plus 7 is 13. 13 is less than or equal to 9. No, so from two element, wait, where is that? We get just 3 and 5, 3 and 6 valid. Okay, now we take 3 element of subsequence. Okay, 5, 6, 7, 5, 3, 5, 6, 7. Now we take 3 element 5, 3, 5, 6. Okay, so the min is 3 and the max is 6. The smallest element is 3 and the largest element is 6. Now we pay attention here. Okay, so we have 3 element, but see, we have 3 element, 3, 5 and 6, but we only check min and max. Okay, but we only check min and max. So min is 3 and max is 6, so it was 9, so 9 is less than or equal to 9, so we take this. Okay, middle element 5, we completely ignore it for the condition. Now let's take another 3, 5, 7. So min is 3 and max is 7, so 3 plus 7 is 10, so 10 is greater than or equal to 9. No, we skip this. Okay, now we take 3, 6, 7. So the minimum element is 3 and the maximum element is 7, so 3 plus 7 is 10. 10 is less than or equal to 9. No, so we skip this also. 5, 6, 7. So the minimum element is 5, smallest element is 5 and the maximum element is 7. So 3, 5 plus 7 is 12. So 12 is less than or equal to 9. No, so from 3 element only valid is 6. Now count become 4 and the valid element is 3, 5, 6. Okay, now we take 4 element of subsequence. See, now we take 4 array, 3, 5, 6, 7. So the minimum element is 3 and the maximum element is 7. So 3 plus 7 is 10, so 10 is less than or equal to 9. No, so we skip this. So the answer is 4 and valid. So see, let's correct all valid ones. 3, 3, 5, 3, 6, 3, 5, 6. Okay, so 3 plus 3 is 6. 6 is less than or equal to 9 years. 5 plus 3, 8. 8 is less than or equal to 9 years. 9 is less than or equal to 9 years, and 6, 7, 8, 9. 9 is less than or equal to 9 years. Okay, so the answer is 4. So see, see, look at all valid subsequences. Every single one of them start with 3 only. Okay, see this, every single one start with 3 only. Why? Because 3 is the smallest number in the array. So when 3 is the minimum, the sum stays same. No, the sum stays small only. Okay, when 3 is not in the subsequence, the minimum become 5 or 6 or 7. So and the minimum plus maximum become too big. Also notice 7 never invalid. Okay, 7 is never in any valid subsequence, because whenever 7 is the max, so 3 plus 7 is equal to 10, so which is already bigger than target. So this is the key observation that helps us to solve the problem efficiently. Okay, now okay, so we understand the problem. We have to return the valid subsequence count, that is min plus max is less than or equal to target. Okay, we have to return their count. So we have understood the problem. Now the question is, how do we think about solving it? So the first thing is always I ask. Okay, see, the first thing I always do is I ask myself what information I do actually need. So in this problem, for every subsequence I only need 2 things only. Okay, for every subsequence I only need 2 things, min and max, the minimum element and the maximum element. So the middle element does not matter at all. So now I ask myself, is there a way to easily find the minimum and maximum of any subsequence? So yes, it was. We can sort the array. If we have instead of this array, we have instead of this 7, 6, 5, 3, what we do, first we sort the array. It's become 3, 5, 6 7, 3 5 6 7. Okay, so we can sort the array first, then in any subsequence, okay, in any subsequence the minimum is always at the leftmost element and the maximum is always at the rightmost element. Okay, now let's take this example only. 3 5 6 7, it was already sorted. So let's take that example only. We can sort first. Okay, 3 5 6 7, it was sorted already. So now I pick any two position, left and right. So left is equal to 0, so the value is 3, and right is equal to 0 1 2 3, the value is 7. 0 1 2 3. Wait, I can pick any position. Okay, so we have array 3 5 6 7, 0 1 2 3. So now I pick any two position, left and right. So our left becomes 0 and right become 2. Okay, 2. So same, left value is 3 and right value is 6. Now minimum is 3 and maximum is 6. So that's it. Sorting made finding min and max super easy. Okay, now we take this example only. See, now the second question, I ask myself how many valid subsequence exist between left and right. So look at this. We take this 3 5 6. So our left is here and right is here, 0 1 2. So 3 is fixed as minimum and 6 is fixed as maximum. So the middle element 5, I can either take it or leave it. Okay, so I have two choices for 5. That give me 2 to the power n, 2 subsequence. Now what if there are two middle elements? So see, now what we have, two middle element 3 5 6 7. So left and right 0 1 2 3. So middle element of 5 and 6. So each has two choices. So total is 2 to the power is 4 subsequence. Now the pattern is 2 to the power number of middle elements. See, the pattern is, look at the pattern, 2 to the power number of middle elements is equal to 2 to the power of right minus left. So the idea is sort the array, then use two pointer. Okay, left and right. If nums of left plus nums of right is less than or equal to target, or subsequence between left and right are valid. Okay, if nums of left plus nums of right is less than or equal to target, if less than or equal to target means all subsequence between left and right all valid count. Okay, so 2 to the power right minus left, move to left forward. Now if nums of left plus nums of right is greater than target, sum is too big, move right backward. Okay, so this is optimal approach. So let's see. So our idea is, first we have to sort the array. Okay, then we use two pointer left and right. If nums of left plus nums of if nums of left plus nums of right is less than or equal to target. What we do? Count plus or equal to 2 to the power right minus left. We move left forward. Then if what nums of left plus nums of right is greater than target, so we move right backward. Okay, now let's try on it. So we have nums of array 3, 5, 6, 7, and the target is 9. 0, 1, 2, 3. So first is sort the array. First we have to sort the array. It was sorted, already sorted. Okay, now we place 2 pointer. Left is equal to 0 and right is equal to 3. Now our count is 0. Okay, so in first iteration, see, left and right. Nums of left plus nums of right. So in nums of left there was 3 and nums of right it was 7. So 3 plus 7 is 10. So 10 is less than or equal to 9, our target. So it was too big, so we move right backward. Okay, now our right become 2. Now our right become 2. So see, now right become 2. So nums of left plus nums of right now. So 3 plus 6 is 9. So 9 is less than or equal to 9. Yes. So now think, left is at index 0, right is at index 2. Okay, left is at index 0 and right is at index 2. How many elements are between left and right? So in between left and right there are only one element. 3, 5, 6. So the middle element is only 5, that is one element. Okay, and so number of valid subsequence is equal to 2 to the power right minus left is equal to 2 to the power 2 minus 0 right minus left. So 2 minus 0 is equal to 2 to the power of 4. Okay, wait, see, let me show you exactly what those 4 subsequences are. How I get 4? Just a minute. See, so 3, 6, take 3 and 6, we skip 5. Now 3, 5, 6, we take 3, 5 and 6. 3 only one, only, see, take only 3 because left itself all alone it also valid. Okay, now 3 and 5, so take 3 and 5. So see, all 4 valid. Okay, they are 4 valid. We take 3 and 6. 3 plus 6 is 9. We take this, it was also 9. 3 plus 3 is 6. 5, 6, 7, 8. Okay, so it was valid. That's how we get. Okay, now count plus is equal to 4, so count is 4. Now we move left forward. Now our left become 1. Okay, now left is 1, 3, 5, 6, 7. 3, 5, 6, 7, 0, 1, 2, 3. Now left become 1 and right become 2 now. So nums of left plus 5 plus 6 is level. So level is less than or equal to 9. No. So sum is too big. We move right backward. Okay, now our right become 1. Right become 1. So now left is equal to 1 and right is equal to 1. So left is not less than right. Here we stop. So the final answer is 4. Here we got the 4. Let's check. So the final answer is 4. Okay, see, all those 4 valid subsequences are exactly what we found by hand. What we have found by hand, it was perfectly matched. Now see, I think you did not get 2 to the power. So see what is meant by this. 2 to the power of right minus left Okay, let me explain what 2 to the power right minus left means. Imagine you have a box and inside that box there are some element. For each element you have exactly two choices. Okay, either include in it in the subsequence or exclude it from the subsequence. Let me show you with example only. Okay, let's take that example only. 3 5 6 left and right. So 3 is fixed as min and left right is fixed, so 6 is fixed as max. Okay, so the middle element is 5. For 5 I have two choices. For 5 I have two choices. Include 5, subsequence is 3 5 6. Exclude, if we can skip 5, the subsequence is look like this 3 and 6. So total two choice, so two choices, 2 to the power of 1 is subsequence. Okay, so right minus left is 2 minus 0 is 2. So 2 to the power right minus left is equal to 2 to the power of 4. So wait, but I just said 2. They where did 4 comes? Did you get? I I have just said 2. For where did 4 come from? Because left itself is also a valid subsequence. Okay, it was also a valid subsequence. Alone it is valid because 3 plus 3 is 6 and our target is 9, so it was valid. And 3 and 5 is also valid. So actually all fours are 3 3 5 3 6 and 3 5 6. So 2 to the power of right minus left is equal to 2 to the power of 2. 4 counts all of them. Okay, now see, if there are two elements in middle, means let's take two elements 5 6 7 left and right term. So 3 is fixed as min and 6, minimum is 3 and maximum is 7. Okay, so 3 has fixed as min and 7 has fixed as max. So see, so the middle element is 5 and 6. For 5 also we have two choices, take it or skip it. And for 6 also we have two choices, take it or skip it. Total is 2 into 2. We have two elements, 2 into 2 is 2 to the power 2 is 4 of subsequence. Okay, so it was 3 7. Include 3 7, skip both 5 and 6. Okay, skip both 5 and 6. 3 5 7, take 5, skip 6. Now 3 6 7, we have skip 5 and we have take 6. 3 5 6 7, we have take 5 and 6 also both. Okay, so right minus left is 3 minus 0 is 3. So 2 to the power of right minus left is 2 to the power of 3 is 8. So the extra 4 come from left alone and combination without right. Okay, so the total is 8. So see, simple rule to remember is right minus left is 0, 2 of 0 is 1, only 1 itself. Okay, right minus left is 1, 2 to the power of 1 is subsequence to subsequence, and right to the power of right minus left is 2 is 4, so 4 subsequence, 4 to 3, 2 to 3 is here subsequence. Okay, at every time left increase by 1, so the count is double because every new middle element has two choices, take it or skip it. Okay, so let me explain you properly what is meant by this. So it's just, so it means a power. Okay, power. So see, 2 to the power 3 means to multiply by itself 3 times, like 2 to the power is 0 1, 2 to the power 1 is 2, and 2 to the power of 2 is 2 into 2 is 4, 2 to the power of 3 is 2 into 2 into 2 is 8. If what 2 to the power of 4, 2 into 2 into 2 into 2 into 3 4, it was 16. Every time the power increased by 1, so the answer double. Okay, like you can understand like this also. Imagine you have a bag of 3 fruits. You have a bag of 3 fruits. Okay, one fruit is apple, second one is banana, and third one is mango. For each fruit you have two choices. For if apple, I have two choices, take or skip. Okay, take it or leave it. For banana also we have two choices, and for mango also we have two choices. So total combination is 2 into 2 into 2 to the 3 is 8. Okay, so in our problem, see 3 3 6, left when left is 0 and right is 2, 0 1 2. Okay, so middle element is 3 at index 1. For that middle element, take it or leave it. So we have two choices. So 2 to the power of right minus left, right 0 minus, so 2 minus 0 is 2 to the power of 4. Okay, so that 4 counts or valid subsequence starting from left. Now let's see. Let's if we have array 6 8 3 3, first we sort the array 3 3 6 8. Okay, it was this one. Okay, I have take that example. Wait, 3 3 6 8, it was already sorted. 0 1 2 3, we have to place two pointer left and right. So left is 0 and right is 3. Now our count is 0. Okay, so in first iteration we take these two. 3 plus 8 is 11. What is our target? 10. So the target is 10. Okay, so the answer is 11. So 11 is less than or equal to 10? No, sum is too big, so we move right backward. Okay, now our right is 2. So 3 plus 6 is 9. So 9 is less than or equal to 10? Yes, it was less than 10. So now our count become 1. Okay, 3 plus 6 9, and our count become. Now see, let that index left is at index 0 and right is at index 2. So right minus left is 2 minus 0 is 2. So 2 to the power of 4, 4 valid subsequence. Let me show you exactly what those are. Okay, so see 3 3 6, we have this much. Okay, now our left is here and right is here, 0 1 2. So the middle element is 3. So 3 is at index 1. Okay, 3 at index 1. So see 3 6, we take index 0, and index 2 we have skipped index 1 here. Okay, so see 3 plus 6 is 9. Next 3 3 6, 3 3 6. So we take all 3, 6 7 8 9 10 11 12. Okay, we take all 3. Now we take this only, our max min and max. It was also 9, so the answer is 9. Now we take single 3, 3 plus 3 is 6. We take only index 0, okay, and we take 3. So index 0 and index 1, so all 4 all valid, okay. Now we move left forward. Now our left become 1, so left is 1. 3 plus 2 is 3 plus 6 is 6, 7, 8. 3 plus 6, 9. Okay, so 9 is less than or equal to 10 years. Now so the answer here we stop our row 10. So 2 minus 1 is 1, so 2 to the power is 2 valid subsequence. So the middle element, no middle element, okay. So we take 3, only one index and 1, and value is 3 and 6, take index 1 and 2, okay. So the count is 6. Now here we stop our row, so the final answer is 6, okay, and the expected answer is also 6. Now see, so we just did rather. Now let's convert exactly what we did into code line by line. So remember our idea, we have to sort the array and we have to place 2 pointers left and right. If sum is less than or equal to target, what we do, count place equal to 2 to the power right minus left, we move left forward. If sum is greater than target, we move right backward, okay. So let's write down the code. First we have to sort the array. Folder we write sort nums dot begin begin and nums dot end, okay. So see, because after sorting, left almost element is always minimum and right almost is always maximum, okay. Without sorting we cannot find min and max easily, that's why we sort the array first. Next we have to precompute power of 2. See, in our Raidan we have calculate 2 to the power right minus left every time, okay. So in iteration 2 to the power is 4, in iteration 3 to the power is 1 is 2, but calculating power again and again is 2, so we compute all power of 2 from 0 to n, okay, and then store them. So we have to store them. For this we write int n is equal to nums dot size and we vector long pivot every power of n. Pivot every power of 0 is equal to 1, and we take a row for n I is equal to 0. Now we start I from 1, I is less than n, I plus plus. Power of power of I is equal to power of I minus 1 into 2 and modulo by mod, okay. So see, wait, so what is so see what so that when we need 2 to the power of 3, we just say power of 3, okay. Instead of calculating again and again, let me show you what is the array look like for n of 4. Power of 0 is 1, 2 to the of 0. Power of 1 is 2, 2 to the of 1, and power of 2 is 4, 2 to the power of 2, and power of 3 is 8, 2 to the power of 3. Okay, so see, the problem says the answer can be very large. Okay, so we have to return the modulo 10 to the power of 9 plus 7. So wait, let me create a variable of modulo also. Int mod is equal to 1e 9 plus 7. Okay, because number can be huge, like 2 to the like so much. Okay, so we keep taking reminder with mod to keep numbers small. Okay, we have to place 2 pointer also. So for this we take int left is equal to 0, int right is equal to n minus 1. Okay, so let's start at index 0. Okay, and in started point and right start at ending point. Okay, next we have to create a count variable also, because answer is wrong, so that's why we create this count is equal to 0. We use long because answer can be very large. Okay, then while loop while left is less than right, so as long we have to stop this also. Next we take this if nums of left plus nums of right less than or equal to target COUNT count is equal to COUNT plus power of right minus left, and we have to mod the row by mod, then left will be left plus plus. Oh, so see, we have wait, power of right minus left, because right minus left give as a number of element between left and right, and 2 to the power of right minus left give as all valid subsequence. Okay, if the condition is no, what we do, we if the target is greater than no, if the sum is greater than target, we move right backward. Okay, so for this else right minus minus, in last we have to return count also, return COUNT count. We have to sort first, we have sort, then next, and we have to sort module, and we take the sign, and then we have fixed 3 pointers also, then left, and let me minimize this. So see, every single line of code is exactly what we did in our Rhino. Okay, there is nothing new. Let's see what happened. So what is wrong? Test case 2, 3, 3, 4, 6. So what happened? If left is 0 and right is 2, so 3 plus 6 is 9, so it was valid. So we take count. So 2 to the power of 4, the count become 4. So we move left forward, left become 1, and okay, if what, left and right will meet, left is less than, where is while loop? Yes. Oh, what happened? It was wrong. Test case. Modification. ऐसे ये तो पास हो गया. -1 output. I think code was right, it was working, but we have to write like I think 1, 2, 3, 4, 5, 6, 7, 8, and please count. It was right. So see, so the mistake is I have written int mod is 1e9 plus 7. It was wrong because see what is wrong, e9 is a double decimal number, is decimal number, not an integer. Okay, so it was decimal numbers. Let's take a point. So we have stored in precision in lost. So this case long calculations happen, so that is why output has become negative values. And it was, so you have to write the numbers. And the second mistake is see, in C++ modulo has higher priority than, okay, so this run as power of right minus left modulo by mod is run first. In count plus result is run second. So but count itself can become very large, so count never get mod applied, so it was happen overflow. Okay, we have fixed that also. So we have, in this we have done two mistake. I have done two mistake. We use integer not double, we have to use integer not double, and is wrong bracket placement, okay, of mod must apply the whole sum, not just power of right minus left. And yes, it was right. Okay, so the time complexity is, see, time complexity is big of n log n, and space complexity is, we have taken variables, so it was big of n power array and sorted delimited. That's all. So the answer is this. It worked.